Hello, welcome back. So in this session we are going to learn about the trigonometric ratios of standard angles. So till now what we have done, we have learned in general what is sine theta, what is cos theta, what is tan theta, and reciprocal of that, that is what is cosec theta, what is secant theta, and what is cot theta. So theta, we have taken the angle in general. It can be 1 degree, 2 degree, 3 degree, or whatever it is there, right? But what happens if somebody asks me what is sine 0 degree or sine 30 degree, sine 45 degree or sine 60 degree or sine 90 degree? We should be in a position to tell them the final answer, as these are the standard angles. So what I suggest you, please remember this table. How do you read this one? Like here, if you see horizontally, it is 0 degree, 30 degree, 45 degree, 60 degree, 90 degree is given. So sine 0 degree is 0, sine 30 degree is 1 upon 2, sine 45 degrees 1 upon root 2, sine 60 degrees root 3 upon 2, and sine 90 degrees 1. And the same way, cos of 0 degree is 1, cos 30 degrees root 3 by 2, and so on. The important part here to understand is tan of 90 degree, it is not defined. Why it is not defined, we will discuss very shortly. Similarly, cosec of 0 degree is not defined, and secant of 90 degree is not defined, and cot of 0 degree is not defined, right? Now, how this table is generated, we are going to derive one by one. So let us start derivation with for the 45 degree, means what is the value of sine 45 degree, what is the value of cos 45 degree, what is the value of tan 45 degree, and so on. All right. So anyway, you know it. If we can find the value of sine 45 degree, cos 45 degree, and tan 45 degree, other three we can find by using the reciprocal concept, right? If you have forgotten the reciprocal concept, I request you to go through my previous videos and come again, okay? Anyway, I hope so you remember. So how to derive this one? So for that, to derive for the 45 degree, first we have to take a right angle triangle. So let us take a right angle triangle, something like this. Okay, so this is my right angle triangle, and it is isosceles as well. So suppose we name it as A and B and C. So as we can say, this is isosceles, means this and this angle is side is same, AB equals to BC. So obviously this angle will become 45 degree, right? And this will also will become 45 degree. All right, now this equal side, let us take the length as A. Okay, now suppose this is A, so obviously this will also be A. Now using Pythagoras theorem, I can find the length of AC. How do we find the length of AC? Pythagoras theorem says that the square of hypotenuse is equals to square of the other two sides, that is AC square equals to AB square plus BC square, right? Now AB is nothing but A, so A square plus BC is nothing but A, so this is A square. So it means that AC square equals to A square plus A square, or I can say AC square equals to 2A square, right? But I'm not interested in AC square. I want to find the length of AC. So AC equals to under root of 2A square, right? That we can write it as under root 2 times of A. That is the length of AC. So we get the length of hypotenuse as root 2 times of A. Now you can consider this angle C as my reference, because I want to find the ratios for 45 degree, right? So now if we want to find the value of sine of 45 degree, right? So how we will find it out? Sine 45 degree is nothing but opposite upon hypotenuse. So opposite is my AB and hypotenuse is my AC. Now what is the length of AB? It is A. What is the length of AC? It is root 2 times of A. So what you can see here, from the numerator and the denominator, A and A will get cancel it out. So what will remain in numerator? 1, and denominator root 2, right? Same way, if we want to find the value of cos of 45 degree, so what happens? It is adjacent upon hypotenuse. So adjacent is BC and hypotenuse is AC, right? So what is adjacent? This is A, and what is hypotenuse? Root 2 times of A. So here also you can see here numerator A and denominator A can be cancelled it out, and you will get 1 upon root 2, right? Same way, if you want to find the value of tan of 45 degree, so that is nothing but opposite upon adjacent. What is your opposite? AB. What is your adjacent? BC, right? So that is nothing but A upon A. So what happens? Numerator and denominator, A and A will get cancel it out. You are getting nothing but just 1. All right. Now, if we can find the value of these three, then the other three is very easy, just the reciprocal of these three. So sine 45 degree reciprocal is cosec of 45 degree. That is 1 upon root 2 can be written as root 2 upon 1 or just root 2, right? Same way, reciprocal of 40 cos 45 degree can be written as secant of 45 degree. That is again root 2 upon 1. That can be written as just root 2, right? Same way, reciprocal of tan 45 degree can be written as cot of 45 degree, that is 1 upon 1 or simply just 1. So what it says that sine 45 degree is 1 upon root 2, cos 45 is 1 upon root 2, tan 45 is 1, cosec of 45 is root 2, secant of 45 is root 2 and cot 45 is 1. I hope you can understand these values. If you want to verify, you can go to the table and you can check it out, right? Here also you can see that sine 45 degrees 1 upon root 2, cos 45 degrees 1 upon root 2, tan 45 is 1, cosec 45 degrees root 2, secant 45 degrees root 2 and cot 45 is 1. Now, same way we are going to derive about the 30 degree and 60 degree, okay? So for that, little bit extra calculation is required, but we'll do it, don't worry. So let us take an equilateral triangle first of all, okay? So as this is my equilateral triangle, first of all, we will name it as A, and this is B, and this is C, right? So what happens, let us take this length as A, so that this length BC will also be A and AC will also be A. So what we will do first we will draw a perpendicular from A to the opposite side, right? Something like this. All right. Now what happens, this when we have drawn the perpendicular, this will be 90 degree, and because of symmetry this length and this length will be equal. Let us name this perpendicular where it touches the BC, call it as D. So the length of BD will become A upon 2. DC will also become A upon 2, right? Now this angle, as it was an equilateral triangle and it was 60 degrees, so this becomes 30 degree. Same way this becomes also 30 degree, right? And this angle B is anyway it is 60 degree as it is a equilateral triangle, right? Same way angle C will be also 60 degree. Now just concentrate here in the triangle A, D and C. So we know the length of AC, we know the length of DC, but we don't know the length of AD. So using Pythagoras theorem, we can find it out the AD length as well, okay? So let us find it out. So what the Pythagoras theorem says that hypotenuse square, that is AC square, equals to AD square plus DC square. All right. Now AC square we know it is A square. AD square we don't know, that's what we have to find it out, and DC square is nothing but A upon 2 whole square, right? Now if we rearrange the terms, we get AD square equals to A square minus of A upon 2 whole square, right? That is nothing but A square minus of A square upon 4. So that if you simplify, you are getting nothing but 4 in the denominator, and this is 3A square minus of A square, right? So that is your AD square. I'm sorry, this will be 4A square, I mean to say, I'm really sorry. Okay, I'll just erase it a bit. So this you will get it as 4, denominator will be 4, and this is nothing but 4A square minus A square. So that is nothing but AD square as 3A square upon 4, right? So now AD is equals to under root of 3A square upon 4, or you can simplify it as AD equals to root 3 upon 2 times of A, right? So your height is nothing, AD is equals to root 3 times upon 2 times A. Now, what happens if you look at the triangle ADC, you have both the 30° and 60°. So what we will do, we'll go to the next page and we'll consider only ADC triangle. Okay, so what is my ADC triangle? So we have considered something like this, right? So this is my A, this is my D, and this is my C, correct? This was my A by 2, and this is my A, and this was my root 3 upon 2 times of A, right? Correct. Now this was my 30° and this is my 60°. So same way what will happen if I write the value of sine 60° considering the angle C. So sine of 60°, same way we will write cos of 60°, and same way we will write of tan of 60°, right? So what will happen? Sine 60° is nothing but opposite upon hypotenuse, that is root 3 upon 2 times of a whole thing divided by a. So a and a from the numerator and denominator will get cancelled it out. You are just getting root 3 by 2, right? Same way if you write cos 60° is nothing but adjacent upon hypotenuse, that is a upon 2 divided by a. So what will happen here? Also a and a will get cancelled it out. You are just remaining with 1 upon 2, right? Same way tan 60 is nothing but opposite upon adjacent, that is root 3 upon 2 times of a divided by a upon 2, right? So what happens? This a upon 2 will get cancelled out. You are just remaining with root 3, right? So this is the value for 60°, right? Now what happens? You can write the same thing for cosec of 60°, right? Cosec of 60° is nothing but 2 upon root 3, right? Same way you can write for secant of 60°, that is nothing but 2 upon 1, that is 2. Same way you can write for cot of 60°, that is nothing but 1 upon root 3. I hope you understand. This is just for 60°. Now if you want to write for 30°, so you have to consider the angle A. So what we will write it as sine of 30°, then cos of 30°, then we will write for tan of 30°. Okay, then we will write for reciprocal of this, that is cosec of 30°, and then secant of 30°, and then we will write for cot of 30°. All right, so sine 30° means opposite upon hypotenuse. So opposite is a upon 2, hypotenuse is divided by a. So if you divide a and a will get cancel it out, so you will get just 1 upon 2. All right, so this is nothing but sine 30 is 1 upon 2. Same way cos 30 is nothing but adjacent upon hypotenuse, right? So cos 30 is opposite up adjacent upon hypotenuse. So that is root 3 upon 2 times of a divided by a. So what happens? A and a will get cancelled it out. You are getting just root 3 upon 2, right? Same way, if you want to find the value of tan 30, opposite upon adjacent, right? So opposite is a upon 2, adjacent is nothing but root 3 upon 2 times of a. So what happens? A upon 2 will get cancel it out, and you will get only 1 upon root 3, right? I request once again to check this calculation properly and try to do yourself as well, and then you can verify, right? So sine 30 is 1 upon 2, so cosec 30 will be 2 upon 1, that is 2. Same way cos 30° is root of 3 upon 2, so secant of 30 will be 2 upon root 3. Tan 30 is 1 upon root 3, so cot 30 will be root 3 upon 1, that is root 3. I hope you have understood the derivation for 45°, 30° and 60°. 0° and 90° we will take up in the next session. All right. So once again, I request you to go through this table and make sure you understand each and every value. Okay. And you have to remember all the values. What is sine 0°? What is sine 30°? What is sine 45°? What is sine 60°? And what is sine of 90 degree, and so on, for cos theta, for tan theta, cosec theta, secant theta, and cot theta. All right. So we see you in the next class, in which we will discuss how to derive the trigonometric ratios for 0 degree and 90 degree. All right. Bye. See you next session.